Number 2, if 24.25 milliliters of hydrobromic acid at 0.250 molar concentration is used to titrate 15.73 milliliters of a rubidium hydroxide solution. Titrate. Thursday. Alright, so we're starting with the given amount of the species whose concentration we know. We know this is a given amount here, and this is the species, the concentration of which we know. Okay, so we start with 20, well, let's see, actually I probably should turn this one sideways. So 24.25 milliliters of hydrobromic acid. Let's see, hydrobromic is HBr. And we're going to put that over 1. If we're going to go from one species to another, and it says what's the molar concentration of the rubidium hydroxide, so you are going from one species to another, then we've got to get this into moles. And the way that I taught you to do that is you're going to first change this into liters, and we use the conversion unit or the equality statement. 1,000 milliliters equals 1 liter. 1,000 milliliters and 1 liter. And then we're going to use this molarity or molar concentration in a fraction form, and we have 0.250 moles of hydrobromic acid per 1 liter of HBr solution. There should be solution over here too. Somebody ask a question?
Yeah, could you not put 15.73 milliliters of rubidium hydroxide solution under the hydrobromic?
Yeah, you'd actually end up with the right answer that way. I've waited till I get down later in the problem because that's when I get into that solution. But I mean, it actually works out that way. So you put this many milliliters here and the 15.73 milliliters of rubidium hydroxide down here, and still manage to come up with a molarity over here, right?
Yeah.
Good. That'll work, because I'll show you when I get there how you get there. Okay? How you can do that, or why you can do that. Okay. All right. So the milliliters are going to cancel here. Liters can cancel here. The HBr solution can cancel here. So we have moles. To go from moles of to go from one species to another, you have to have a molar ratio. And you get a molar ratio from a balanced equation. So we need a balanced equation. We're reacting with HBr, and it says it's a solution, gives you a concentration. It's got to be dissolved. So we could go ahead and call that aqueous. You could look it up if you wanted to on the solubility rules and figure it out. And rubidium hydroxide, RbOH, rubidium has a 1+ charge and hydroxide has a 1- charge, and it says that's a solution. So we can say that's aqueous. And then when those two react together, you're going to have the front part of this formula going with the back part of that one. That's HOH. And then rubidium and bromine, Rb and Br. That has a 1+ charge, that's a 1- charge, so that's balanced already. And if you look it up on your solubility rules, this is really the only one you have to look up, or might have to look up on your solubility rules. You can use the solubility rules to help out, but that's the one you kind of have to look up if you haven't memorized the solubility rules, and that's not required in this class. So bromine or bromides are listed right here under soluble. Exceptions are silver, lead, and mercury, and this is rubidium, so it's not an exception. So this is going to be aqueous. And so we need to balance the overall equation. Let's see, HBr, Rb, O, and H.
Can you move it out just a second?
Sure.
You could.
You already have the H.
Oh, I do, don't you? Yeah, you're right. Okay, so we don't need that twice, do we? Okay. Let's see, we've got 2 H's right now on this side. See, there's our dividing line. We've got 2 H's, 1 Br, 1 rubidium, and 1 oxygen. 2 H's, 1 Br, 1 rubidium, 1 oxygen, so it's balanced. So we just need a molar ratio that's 1 to 1 here to go from this species to this species. So 1 mole of HBr and then 1 mole of rubidium hydroxide on the top. Now, we cancel the units and species here, so now we have moles of rubidium hydroxide, and to get to the molar concentration, we need to somehow arrange it so that rubidium hydroxide, the moles of rubidium hydroxide are above liters of that rubidium hydroxide solution. And while we don't have liters, we do have milliliters. I crossed it up there, but not down here, did I? Okay, so we can put 1 over 15.73 milliliters of the rubidium hydroxide solution. And so, let's see, this is where you were asking about, could you put that right here, right? That's where you were asking about this. I put it over here because I want to put moles on top of that solution. But it works out if it's up here. Okay, as long as the math works out and you get everything in the right order when you're done, it doesn't really matter that you put it right here. Okay, I don't usually teach it that way because I try to wait till I get past the molar ratio step. Okay, and then we just need. That was when we were doing. That's the next problem. We're doing a dilution problem. Okay. So then we want to change this into liters. We already have the equality statement here. 1,000 milliliters, 1 liter on the bottom. Okay, and we can cancel milliliters. We now have moles of the rubidium hydroxide over liters of the rubidium hydroxide solution. If you want to shorten this up a little bit, the 1,000 here and the 1,000 here cancel each other. Oh, they're on the end. Here's the 1,000, this 1,000, they cancel each other. That will make the math go a little bit faster. And so we've got, let's clear out some of these problems here. 24.25 times 0.250, and then enter and divided by 15.73. So we get 0.385 for 100, 445.101, 44501. We have units of moles rubidium hydroxide over liters of rubidium hydroxide solution. And that is what molarity is, so we can shorten that up in the next step. Going through the problem, this one right here, this calculated number has the least number of digits of the measured and calculated numbers, and it has 3. So we can round this off to 3 digits like this, underlining all the digits past the first 3. Recall leading zeros are not significant. And we can do 0.385 moles of rubidium hydroxide over liters of rubidium hydroxide solution is molarity of the rubidium hydroxide solution. And that's what the question is asking for. What's the molar concentration of rubidium hydroxide?